Assalamu alaikum. We will continue our lesson about rational functions. Part 5 Objective: to study the variations and to draw the graph of a rational function having a horizontal asymptote. Consider the following exercise. Given the function f defined by f of x equals 2x squared minus 4x over x squared minus 2x minus 3, and let C be its representative curve in an orthonormal system OIJ. Number 1, determine the domain of definition of f. 2, find the limits of f at the boundaries of its domain. Deduce the equations of the asymptotes. 3, find f prime of x and set up the table of variations of f. 4, draw C. Now part 1, find the domain of definition of f. We take the denominator different from 0, then x is different from minus 1 and x is different from 3. So the domain of definition is minus infinity minus 1 opened, union minus 1 3, union 3 plus infinity. Find limits of f at the boundaries of the domain. Deduce the equations of the asymptote. First, we start by limit as x tends to minus 1 and x is less than minus 1 of the function. It is equal to 6 over 0 plus, which is plus infinity. And limit as x tends to minus 1 and x is greater than minus 1 of the function. It is equal to 6 over 0 minus, which is minus infinity. Then we deduce that the line of equation x equals minus 1 is a vertical asymptote. Now limit as x tends to 3 and x is less than 3 of the function. It is 6 over 0 minus, which is minus infinity. And limit as x tends to 3 and x is greater than 3 of the function. It is equal to 6 over 0 plus, which is plus infinity. So we deduce that the line of equation x equals 3 is a vertical asymptote. Now we find limit as x tends to minus infinity of the function. It is equal to limit as x tends to minus infinity of 2x squared over x squared, which is equal to 2. And limit as x tends to plus infinity of the function. It is also equal limit as x tends to plus infinity of 2x squared over x squared, which is also equal to 2. Then we deduce that the line of equation y equals 2 is a horizontal asymptote. Now find f prime of x and set up the table of variations of f. Please note that f of x, it is in the form of u over v. Then f prime of x, it is equal to u prime v minus v prime u over v square. We make the calculations and continue, so we get minus 12x plus 12 over x squared minus 2x minus 3 squared. We then make the sign table of f prime of x and then the table of variations of f. Part 4, draw C. First, we draw the asymptotes. X equals minus 1, x equals 3, and y equals 2. Then we locate the point 1, 0.5 from the table of variations. And then we find the intersection of the function with x-axis and y-axis. Then depending on the table of variations, we can see that for x belongs minus infinity minus 1 opened, the function is increasing. For x belongs minus 1, 3 opened, the function is increasing till the maximum point 1, 0.5, then it is decreasing. And for x belongs 3 plus infinity, the function is decreasing. Then we draw the curve of the function f depending on the table of variations. So this is the curve of the function f. Now solve the following application.